Brief description. Description of SSDAC Alcatel make. This is a digital axle counter equipment for single track sections which counts the axles and decides the track occupancy status of a track section. The word AZLS used hereafter to denote the equipment. It can be used for a straight track section, a section with a single turnout or a set of points. It consists of two or more detection points known as ZP30CA2. A separate evaluator unit is not required. ZP30CA2 contains a 2 out of 2 vital microcomputer system to count the axles, establish track occupancy, and provide this information to the block or interlocking equipment. Reference count direction, that is RCD. The reference count direction, RCD, is defined for the entire layout independent of the direction of train movement. The use of RCD ensures that the correct order of counting into and out of a section is maintained throughout a series of detection points. Without the RCD, the system cannot be correctly configured. When a train passes detection point number 1 in the direction of the RCD or detection point number 2 in the opposite direction to the RCD, axles are counted into the track section ATS1 and axles are counted out of the track section ATS1 when a train passes detection point number 1 in the opposite direction of RCD or detection point number 2 in the direction of RCD. The rail contact, which is first passed by an axle in the axle counter, reference count direction is defined as rail contact 1 or SK1, and correspondingly the second one should be rail contact 2 or SK2. Design features. AZLS is designed for use as a train detection system in station section and block section. Maximum 3 detection points can be assigned to one section. Maximum 2 sections can be assigned to one detection point. The maximum length of track section is limited by the power supply to the detection point and the data communication between two detection points. System architecture. The AZLS, consisting of double rail contact SK30H that is mounted on rail and an electronic unit EES30CA2 that is contained in the trackside housing, is positioned at each end of the track section to be supervised with a 2-wire fault tolerant link which is FTL between the two. It consists of one analog board and one evaluator board. A second slot for an evaluator board is available to enable the rail contacts to be double utilized to supervise a second neighboring section. Alternatively, an evaluator board with ISDN interface to the ACE of the AZLM axle counter system may be inserted. The main parts of the system are given below. Outdoor equipments, that is detection point ZP30CA2. It consists of rail contact, that is SK30H, trackside electronic unit, that is EES30CA2. Indoor equipments. It consists of vital relay, SM's reset box, that is ERBS02. Outdoor equipments, double rail contact, that is SK30H. Description. Its main parts are transmitter head, receiver head, protective hose, fixing parts for hose. The SK30H consists of two transmitter heads, that is TX, installed on the outer side of the rail and two receiver heads, that is RX, installed on the inner side of the rail directly opposite to the respective transmitter heads. The rail contact is electrically insulated from the rail. The transmitter head contains the transmitter coil. The casing of the receiver head is made of aluminum alloy. It contains the receiver coil. Installation. Selection of installation point on rail. The rail contact is mounted on the rail as shown in figure between two sleepers. Any embossments on the rail web must be removed. On double track lines, the rail contact should be mounted preferably on the outside rail. Rail contact has to be installed at a distance not less than 1 to 2 meters from a rail joint, that is fish-plated or welded or insulating joint. Rail contact has to be installed at a distance of greater than or equal to 2 meters from the adjacent rail contact of same type, that is SK30H, in order to avoid mutual interference. The operator must ensure that other equipment used or installed at the track does not influence the correct functioning of the detection points EZP30H of AZLM, example, detection points of other manufacturers. Step 1. Rail mounting holes are to be drilled in the correct position as shown in the figure to ensure reliable working of the system. Where A is equal to height of the rail contact, mounting holes from the base of the rail. H is equal to height of the rail, which depends upon the rail profile. B is equal to the diameter of the hole. B is equal to 13 millimeters plus or minus 0.2 millimeters. C is equal to inter-separation distance between the holes. C is equal to 148 millimeters plus or minus 0.2 millimeters. The following approximation formula can be used for calculating the height of the holes on the rail web from the base of the rail. A is equal to 0.409 into H plus 1.5 in millimeters. Following table gives an indicative example of the height of the rail contact mounting holes as per various rail profiles. For 90-pound rail profile, the height of the center of the holes from the bottom of the rail is 56 millimeters. For 52 kilogram rail, its value is 63 millimeters, and for 60 kilogram rail, its value is 68 millimeters. Step 2. The 3 holes of diameter 13 millimeters are to be made on the rail web. For this purpose, use of drilling jig, which is shown in the figure, is recommended. The drilling jig consists of drilling template, mounting device for the drilling machine, templates for the standard rail profiles, fastening device, drilling machine. Optionally, drilling machine may be made available from ELDNE. Step 3. The rail contact is mounted on the rail with transmitter heads on the outside and the receiver heads on the inside of the rail. The 3M12 bolts must be tightened to 45 Newton meters by means of an adjustable torque wrench supplied only with a toolkit ETU 001. Each transmitter head is mounted on an aluminium casting with 2M8 bolts. It is important that the teeth and the grooves of the aluminium casting and the transmitter head are correctly lined up. The 4M8 bolts must be tightened to 25 Newton meters by means of an adjustable torque wrench supplied only with the toolkit ETU 001. Note: after tightening the nuts, the bolts should protrude a minimum of 2 millimeters. If it is less than 2 millimeters, the transmitter head and the aluminium casting must be rechecked for correct fitting. Nylon bushes are inserted into the holes of the brackets for the protective hose to insulate it from the rails. Mark the rail contact integral cables before putting them inside the protective hose as SK1 or SK2 according to reference count direction, so that after taking out from the other end of the protective hose, those cables can be identified easily. The protective hose must be cut to the correct length before the cable is inserted. The hose must be made watertight with a rubber seal on the rail contact side and the hose clamp on the side of the EAK. The length of the protecting hose must be adequate to ensure that the necessary support for the cable at the heads is provided. Exposed integral cables or rail contact at the transmitter and receiver side should have adequate radius of curvature so as to avoid stress on the cable. Measure should be taken that this exposed part of the cable does not touch the sharp edge of the ballast. The integral cables of the rail contact are available with 3 different lengths: 4 meters, 5.5 meters and 8 meters. Choosing the right length of integral cable is very important before installation. The cable should not be shortened. Deflector plates are to be installed to protect the rail contacts from hanging metal objects from passing train. Deflector plates should be placed at a distance not less than 25 centimeters from the track device. Outdoor equipment trackside electronic unit, that is EES30CA2. The electronic unit EES30CA2 does the following functions: energize the TX heads, detect and count the wheel pulses, monitor the rail contacts, run self-test, transmit telegrams containing count and supervision information to the detection point of the same section via a modem circuit. Operate the relay interface with the track section free or occupied indication. It is housed in a mushroom cover near the track device that it controls, and if it is provided inside a location box, then it is provided with dust cover. Parts of EES30CA2. It mainly consists of analog board, evaluator or digital board, cable to transmitter 1, receiver 1, transmitter 2, receiver 2, power supply, next detection point, motherboard, diagnostic interface, analog card. Its main features are generation of 24-volt supply for working of EES30CA2, generation of 30 kHz and 28.6 kHz signals for the transmitter coils, amplification of the signal received from the receiver, to demodulate the phase modulated signal and to rectify it, generation of analog wheel pulse, that is MESUB, generation of digital wheel pulse, that is RADIMP, digital card or evaluator. Its main features are: it does the wheel count, it determines reference count direction, supervises rail contacts, codes telegrams, compares counts from adjacent evaluator card of AZLS and evaluates free or occupied status, controls and supervises relay circuit for AZLS. Depending upon the application, 2 types of addition evaluator PCB could be inserted in the spare slot of the EES30CA2 of AZLS. Digital PCB of AZLS if EES30CA2 concern is used for controlling 2 sections. Digital PCB of AZLM if AZLS is to be interfaced with the central evaluator of AZLM. Dip switch settings. Each ZP30CA2 has its own 15-bit address. The address is set for CPU 1 on evaluator board 1 with switches S1 and S2. For CPU 2 on evaluator board 1 with switches S3 and S4. For CPU 1 on evaluator board 2 with switches S5 and S6. For CPU 2 on evaluator board 2 with switches S7 and S8. To set a 1-press switch on the end, which is named open. To set a 0-press switch on the other end. Note: Before setting the switches, pull out the analog PCB. Ensure that the switches have been firmly set to the correct position. The address is set on the motherboard with the two DIP switches, that is, one with bit 1 to 8 and the other with bit 9 to 15. But 16 is not used. Bit 1 to 13 is used for the detection point processor number. Bit 14 is used to indicate whether the detection point is related with a point zone or a straight section. It is set at 0 if it is a straight section and it is set at 1 if it is located in a point zone. Bit 15 defines the counting direction corresponding to the RCD. It is set at 0 if train movement over the rail contacts in direction of RCD causes an in count to the section. It is set at 1 if train movement over the rail contacts in direction of RCD causes out counts. By dividing the address range, it is distinguished whether a section is controlled by 2 or 3 detection points. All addresses of a section must be within the defined address range. The addresses of all detection points must be sequential in axial counter reference direction and without gaps. When double utilizing a rail contact, for two sections, all detection point processors of the two involved sections must have different addresses. Installation of trackside electronic unit, that is EES30CA2. Identify the location for mounting the mushroom cover or the location box where the EES30CA2 is to be installed. Identify the route for laying the integral cable in a protective hose from EES30CA2 to rail contact. EES30CA2 can be connected to the SK30H using different cable lengths 4 meters, 5.5 meters and 8 meters. The cable shall not be shorted or joined. If found in excess, then it can be kept coiled. Connections with rail contact. SK30H is connected to the EES30CA2 using 0.2 by 24 twisted shielded cable. Each transmitter and receiver heads are connected to EES30CA2 using separate cable. The SK30H is connected to the terminals of the electronic unit as per the table below. Separate terminals are provided on EES30CA2 for connecting transmitter and receiver cables from SK1 and SK2. Transmitter cables from SK1 having colors black and transparent are connected to S1 and S2 terminals respectively. Receiver cables from SK1 having colors black and transparent are connected to E1 and E2 terminals respectively, whereas blue-colored cable is connected to E3 for grounding purpose. Same color coding is used for connecting transmitter and receiver cables of SK2. The other connections of the EES30CA2 are furnished in the following table. Data link 1 and 2 of outer slot is connected to terminals 5 and 21 respectively. Data link 1 and 2 of inner slot is connected to terminals 6 and 22 respectively. 24-volt power supply positive and negative are connected to terminals 2 and 18 respectively. 24-volt relay supply positive and negative are connected to 39 and 33 terminals via a 500 mA fast blow fuse for evaluator card at outer slot. Relay coil for evaluator card at outer slot is connected to terminals 40 and 34 respectively. 24-volt relay supply positive and negative are connected to 42 and 36 terminals via a 500 mA fast blow fuse for evaluator card at inner slot. Relay coil for evaluator card at inner slot is connected to terminals 43 and 37 respectively. Power supply to EES30CA2. 24-volt DC supply whose range is between 21.5 volt DC to 27.6 volt DC with a maximum cable resistance of 5 ohms. 60-volt DC supply whose range is between 54-volt DC to 72-volt DC with a maximum cable resistance of 30 ohms. 110-volt DC supply whose range is between 116-volt DC to 124-volt DC with a maximum cable resistance of 270 ohms. An overview or summary of working. When a wheel passes over the rail contact, a phase reversal of the receiver signal will take place in the track device. This information will be sensed by the evaluator card and it will be processed by CPU 1 and 2 of the evaluator card. The CPUs will process the data independently and will tally the data before giving an output. CPU 1 and 2 control two independent relays, Relay 1 and Relay 2. As soon as section occupied information is processed by the CPUs, they will drop Relay 1 and 2, and section occupied red LED indication will appear. These relays are connected to indoor via a relay interface. For section clear or occupied information, CPU 1 and 2 of the one detection point will communicate with CPUs of the other end detection point via a modem. Similarly, when train goes out of the track section, it will be sensed by the evaluator card of the particular detection point, and this information will be shared with the other end detection point, and if in counts and out counts match, then CPU will drive the relay 1 and 2 and section clear green LED indication will appear. Indoor equipments. Vital relay. It is an AC immunized Q-type 24-volt 1000 ohms and 8F by 8B relay. Reset relay. QNA1 AC immunized Q-style 24-volt and 8F by 8B relay is used. Connection diagram of vital relay. Connection diagram of reset relay. SM's reset box, that is ERBS02. Preparatory reset facility has been provided for AZLS. Preparatory reset is initiated through an external relay circuit which reverses the polarity of the supply voltage to one of the detection points of the section. It can also be initiated by two buttons on the evaluator board. The system goes into preparatory reset mode if any one of the two detection points receives the preparatory reset command. After the system goes into preparatory reset mode, a train needs to be piloted through the section, and when the in count and out count matches, then only the section will be cleared. ERBS02 is the reset box which provides the basic resetting pulse, that is 24-volt DC for reset relay, which is used for a polarity reversal of a power supply to the EES30CA2 for approximately 3 seconds. Front panel of ERBS02 consists of reset key, push button, reset counter, power on indication yellow LED, preparatory reset indication green LED, line verification indication yellow LED, section clear or unoccupied indication green LED, section closed or occupied indication red LED. Additionally, a buzzer is provided to give audio indication that the 3 seconds reset pulse is on. Following steps are to be followed to initiate a reset. The SM inserts the key, turns it to clockwise and then pushes. If optional cooperative reset key is provided, this has also to be turned simultaneously by another authorized person. For this, H and R to be shorted at selection jumper J1 on PCB. If the cooperation or line verification is not required, then P and R are to be shorted. While key is in turned position, the reset push button is pressed momentarily. Buzzer sounds for 3 seconds and then stops. The key is then turned back anti-clockwise and taken out. A reset operation is only possible when section is occupied or disturbed. When reset is initiated, ERBS02 front panel indicates that the system is under reset state by means of the preparatory reset, that is green LED. The section occupied, that is red LED, also glows indicating that the system is waiting for a train movement through the section. After the train is piloted through the section and when in-count and out-count matches, then only section clear, that is green LED glows. ERBS02 reset box terminal connection details. Power supply to EZP30CA2. 2 wires per detection point are required for the power supply to the detection point. The limiting factor for the supply of the detection point over a long distance is the wire diameter and hence the resistance of the wires in the cable. The maximum cable loop resistance is specified for the different power supply options is given in the following table. If 2 evaluator boards are used in one detection point, the power consumption is typically 5 watts. The following table lists common wire sizes and their resistance per kilometer. The following table lists the achievable cable lengths due to power supply voltage drop limitations while using quad cable and PDCU for a superimposed circuit between EZP30CA2 to EZP30CA2. For communication with the other detection points, a physical communication link must be needed. The system uses 2-wire CCITT V23 semi-duplex communication protocol at 1200 bits per second. The maximum transmission distance is approximately 30 kilometers with a 0.9 mm diameter quad cable having maximum resistance of 56 ohms per kilometer and capacitance of 45 nanofarad per kilometer. For better reliability, the right pair of star quad cable should be used with proper terminations. Between EZP30CA2 to indoor equipment. With 0.9 mm diameter quad cable, maximum transmission distance is 38 kilometers. Between EZP30CA2 and ACE of AZLM. With 0.9 mm diameter quad cable, maximum communication distance is 13 kilometers. Earthing. Earthing of EES30CA2. EES30CA2 has to be connected to the earth return rail with a copper cable of 25 square millimeters or an iron cable of minimum 50 square millimeters. If earth return rail is not available, then housing has to be earthed to a suitable low inductance that is lesser than 40 microhenry and low resistance that is lesser than 4 ohms. Earthing of quad cable, it shall be less than 1 ohm. Earthing of mushroom cover. Mushroom or dust cover to be earthed with 25 square millimeters copper cable along with lug. Its earth resistance should be less than 1 ohm. Earthing of the screens of all 4 numbers of the rail contact cable. First, the insulation of all 4 numbers rail contact cables are to be removed up to a length of approximately 45 millimeters and the screens to be connected to the earthing bar of EES30CA2 by using the clips supplied with the equipment. For details, refer to topic 11, that is reference material. Maintenance. During maintenance of AZLS, diagnosis can be done by using toolkit or test equipment, that is ETU001. Using the LEDs. Using toolkit or test equipment, that is ETU001. The toolkit needs to be intended along with AZLS. It is used for measurement of various signal voltages and frequencies of EZP30H. Content of ETU001. Test case. True RMS digital multimeter with probe set which is of type Fluke 1771 number. Extended wire socket to interface with diagnostic plug 1 number. Selector switch on panel base 1 number. Adjustable reversible torque wrench which is of type NOT bar 6013011 number. Deep socket inserts with 13 mm and 19 mm, one set. 19 mm combined double-ended spanner, one number. Dummy wheel, one number. Screwdriver individual which is of type Wago 2101191 number. Screwdriver set which is of type Taperia 812, one set. Screwdriver individual which is of type Taperia 932, one number. For adjustment, the test equipment must be connected to the diagnostic port of EAK and the transmitter heads are moved upward or downward along the serration if necessary. The selector switch position 1 shows the value of the output of first internal DC-DC converter, that is channel 1 in analog card. This should be within the range of 22 volt DC to 35 volt DC. The selector switch position 2 shows the value of output voltage of second internal DC-DC converter, that is channel 2 in analog card. This should also be within the range of 22 volt DC to 35 volt DC. The selector switch 3 is off position. The selector switch position 4 is used for measuring MESAB1, that is rectified voltage of SK1 without and with dummy wheel. The value of MESAB1 should be within 80 mV to 1000 mV depending upon the drill position and rail profile. This should be positive without dummy wheel. After placing the dummy wheel on RX1 vertically on the center, the MESAB1 voltage should be negative. Note: in ideal condition and for proper adjustment of rail contact, MESAB1 voltage without dummy wheel should be equal to the MESAB1 voltage with dummy wheel but having an opposite polarity. Selector switch 5 is used for measuring peg 1, that is reference voltage for SK1. Value of peg should be equal to MESAB, that is without wheel, with a tolerance of plus or minus 2%. Selector switch 6 is of position. Selector switch 7 is used for measuring MESAB2, that is rectified voltage for SK2 without and with dummy wheel. Selector switch 8 is used for measuring peg 2, that is reference voltage for SK2. Steps to adjust the rectified voltage, that is MESAB. MESAB1 rectified voltage for SK1. MESAB2 rectified voltage for SK2. Peg 1 reference voltage for SK1. Peg 2 reference voltage for SK2. Measurement of MESAB1 and peg 1. Step 1. Keep the selector switch at position 4. MESAB1 for SK1 is measured. First, use the potentiometer, that is R2 on analog board, to set the MESAB1, that is rectified voltage 1 without dummy wheel, to positive maximum. Then MESAB1, that is rectified voltage 1 with dummy wheel, is measured by placing the dummy wheel over receiver of SK1. If there is a big difference between the positive MESAB1, that is without wheel, and the negative MESAB1, that is with wheel, then the transmitter head should be pulled up or pushed down. Taking the transmitter head upwards increases the negative MESAB1 and decreases the positive MESAB1 and vice versa. For proper adjustment, the positive MESAB1 should be greater than negative MESAB1 by a value not less than 30 mV for achieving suppression of spoke trolley wheels. It is recommended that the adjustment should be done using a spoke trolley wheel that is normally used in the section. For fine adjustment, the potentiometer R2 on the analog board may be used. Step 2. Turn the selector switch to position 5 for measuring the value of reference voltage for SK1 peg 1. This can be adjusted by using the potentiometer R1 on the analog board. Peg 1 is made equal to the value of MESUB 1 as measured without the dummy wheel. Tolerance is plus or minus 2%. Measurement of MESUB 2 and Peg 2. Step 1. Keeping the selector switch at position 7, MESUB 2 for SK2 is measured. First, use the potentiometer, that is R4 on analog board, to set the MESUB 1, that is rectified voltage 1, without dummy wheel to positive maximum. Then MESUB 2, that is rectified voltage 2 with dummy wheel, is measured by placing the dummy wheel over receiver of SK2. If there is a big difference between the positive MESUB 2, that is without wheel, and the negative MESUB 2, that is with wheel, then the transmitter head should be pulled up or pushed down. Taking the transmitter head upwards increases the negative MESUB 2 and decreases the positive MESUB 2 and vice versa. For proper adjustment, the positive MESUB 2 should be greater than negative MESUB 2 by a value not less than 30 mV for achieving suppression of spoke trolley wheels. It is recommended that the adjustment should be done using a spoke trolley wheel that is normally used in the section. For fine adjustment, the potentiometer R4 on the analog board may be used. Step 2. Turn the selector switch to position 8 for measuring the value of reference voltage for SK2, that is Peg 2. This can be adjusted by using the potentiometer R3 on the analog board. Peg 2 is made equal to the value of MESUB 2 as measured without the dummy wheel. Tolerance is plus or minus 2%. The selector switch 9 is off position. The selector switch 10 and 11 are used during maintenance of AZLS. The selector switch 10 is used for measuring modem transmitter level, and selector switch 11 is used for measuring modem receiver level. Measurement of voltage and frequency of the transmitter. Measurement of voltage and frequency of the transmitter heads are to be measured by the true RMS multimeter only. For this purpose, additional probe set is provided with ETU 001. These readings are available at the connectors of transmitter cables for both SK1 and SK2. The adjustment details carried out during installation or periodic maintenance for the detection point, and it should be noted in the log sheet for future reference. Using LEDs. It has been explained in the troubleshooting part. Parameters of log sheet. Rectified voltage, which is MESUB without dummy wheel, is 80 to 1000 mV. Rectified voltage with dummy wheel is minus 80 to minus 1000 mV. Reference voltage, that is Peg, which is same as rectified voltage without dummy wheel. Tolerance plus or minus 2%. Transmitter frequency for SK1 is 30 to 31.25 kHz. Transmitter frequency for SK2 is 27.4 to 28.6 kHz. Transmitter voltages is 40 to 64 volt AC. Troubleshooting. LED indications of EES30 CA2. LEDs are provided on the analog and evaluator or digital cards to indicate different status of the system. Different LED indications are shown in the following table for analog card. H1 one red LED normally remains off when there is no wheel on SK1. When there is a wheel on SK1, this LED lights. H1 2 green LED normally keeps flashing, indicating that no wheel is approaching SK1. That is, MESUB 1 is within tolerance limit. It goes off when a wheel approaches SK1. H2 one red LED normally remains off when there is no wheel on SK2. When there is a wheel on SK2, this LED lights. H2 two green LED normally keeps flashing, indicating that no wheel is approaching SK2. That is, mess up 2 is within tolerance limit. It goes off when a wheel approaches SK1. H3 one red LED remains off when 24 volt DC required for card functioning is within tolerance limit. It lights when this voltage goes out of tolerance. H3 two green LED remains on when 5 volt DC is available. It goes off when this voltage is not available. H1 two green LED normally keeps flashing, indicating that no wheel is approaching SK1. That is, mess up 1 is within tolerance limit. It goes off when a wheel approaches SK1. H1 one red LED normally remains off when there is no wheel on SK1. When there is a wheel on SK1, this LED lights. H2 two green LED normally keeps flashing, indicating that no wheel is approaching SK2. That is, mess up 2 is within tolerance limit. It goes off when a wheel approaches SK2. H2 one red LED normally remains off when there is no wheel on SK2. When there is a wheel on SK2, this LED lights. Different LED indications are shown in the following table for evaluator or digital card during system operation. H1 one green LED normally keeps on flashing while transmitting data. H1 two green LED normally remains off. It lights when CPU 1 indicates a fault during self-test of analog part. H2 one green LED normally keeps on flashing while transmitting data. H2 two green LED normally remains off. It lights when CPU 2 indicates a fault during self-test of analog part. Different LED indications for digital card are furnished in the following table during system operation. H1/H5 one green LED remains permanently lit when preparatory reset input is provided. Otherwise, it remains off when preparatory reset input is not provided. H1/H5 two green LED remains permanently lit when voltage is present on relay coil, that is section clear. It, however, remains off when voltage is not present on relay coil, that is section occupied or disturbed. H2/H6 one green LED remains permanently lit when telegrams from all other detection points are received. Otherwise, it remains off when telegrams are missing. H2/H6 two green LED keeps on flashing when telegrams are getting transmitted. Otherwise, it remains off when no telegrams are transmitted. H3/H7 one red LED remains permanently on when negative axles are counted in the section. It remains off after accepting reset. It keeps on flashing after restart. H3/H7 two green LED remains permanently lit when reset command is accepted. It remains off when no reset command is present or it is being rejected. It keeps on flashing when sweeping action is taking place in preparatory reset. H4/H8 one red LED remains permanently lit in case of any disturbance of its own detection point. In case of disturbance occurring in other detection point, this LED keeps on flashing. H4/H8 two red LED remains permanently lit in case of any defect of its own detection point. In case of defect occurring in other detection point, this LED keeps on flashing. Do's and don'ts. Always refer correct documentation. Never practice any self-made guideline not recommended in manual. Always use recommended tools. Tools other than those recommended in the manual can cause damage to the system and hence is not recommended. Selection of installation point on rail to be strictly followed as per manual. Never bypass mandatory recommendation as stated in the manual. EES30 CA2. Whether installed inside location box or outside, recommendations to be strictly followed as per the manual. Recommendation, if not followed, can damage the sensitive electronics. Power supply being most important part of the installation, all requisite recommendations should be strictly followed as per the manual. Never use inferior or unreliable power source. Earthing to be followed as per railway practice. All point-to-point run-through terminations to be checked. For communication, matched pairs of cables to be used. Never use unmatched cable pair. Do not make wires parallel for communication. Adjustments and measurements to be strictly done with toolkit ETU 001 only. Never use any other tools for adjustments and measurements. Trolley suppression is applicable only for light spoke trolleys. Procedures to be followed as per manual. Never over-adjust beyond recommendation as per manual. Address setting to be strictly followed as per manual. Never use same address for different detection points. Reset box connection to be strictly followed as per manual. Connection of reset relay to be strictly followed as per manual. Ensure proper reset voltage reaches at reset relay coil after cable loss. Log sheet to be always updated and kept as future reference. Applications. AZLS can be used for station yard, that is, straight section and point zone block proving. Track configurations. Straight section. A detection point is positioned at each boundary of a track section. Point zone. To supervise a set of points, a detection point is installed at each exit to the section. Block proving. Limitations. It can be used for only single section applications. Maximum length allowed between two EES30 CA2 is 30 kilometers with 0.9 mm diameter. Maximum length allowed between EES30 CA2 and indoor equipment is 38 kilometers with 0.9 mm diameter quad cable. If the AZLS EES30CA2 is connected to the central evaluator of AZLM for centralized monitoring, then the maximum length allowed between AZLS and the central evaluator is 13 kilometers. Miscellaneous. Calculation of fuse ratings of current consumption. This table will help to calculate the fuse rating of the 24-volt DC and 60-volt DC main power supplies. For trackside electronic unit with single evaluator whose current consumption per unit is 0.65 ampere. For trackside electronic unit with double evaluator whose current consumption per unit is 0.93 amperes. For vital relay and reset relay, the current consumption per unit is 0.12 ampere. For reset box with line verification box, current consumption per unit is 0.3 ampere. As an example, for an AZLS system having 5 detection points and 2 sections with one EES30 CA2 having double evaluator cuts, the total of maximum current consumption based on the above table will be 4.61 amperes. Therefore, the indoor fuse for 24-volt DC main power supply should be of 5 amperes. In a location box, if there is one EES30 CA2 with 2 evaluator cards, then based on the above table, the maximum current consumption for the system inside that location box will be 0.93 amperes. Therefore, the fuse for the system in that location box should be of 1 ampere.